Hello and welcome to this tutorial. This tutorial is covering a feature that was recently added in Embrace 3D, which is the ability to conduct lifting analysis for plate girders. So here you will notice this new line, lift points, which is checked here. We are here modeling a simple girder which has a radius of curvature of 1200 feet. This is the length of the girder. These are the material properties. All is very standard. We have two transitions here. The girder is non-prismatic. We have two lift points which are located here and there. Okay, you don't need to go into such accuracy. It's probably too much, but okay, that's the case here. The distance from the line of support to the top of the girder, this is an important parameter which will dictate the rotation, the rigid body rotation of the girder under its own curvature. Here it's equal to 30 inches. And what that means really is the distance between the top of the girder to the axis of rotation on the lifting equipment. Okay, so that's something which is really here. It's by default, it's proposed equal to 30 inches by the program. We believe this is a pretty standard value, but feel free to modify it depending on the lifting equipment. 30 inches again is a pretty standard value. We can click on this button, doesn't do any harm. We have a 2 feet mesh size. These are the cross-sectional profiles. We're assigning profiles to the different segments here. The girder is non-prismatic, and we can just click on default here to find the left and right elevation. Okay, well, in this case here, we have a constant web depth, so we can just hit this button and it will give us the left and right elevations. We are activating the whole length of the girder. We are also running an eigenvalue buckling analysis, and instead of clicking on the run button, we can just go to the viewer. The model is already run, and running the model would take about a minute or two. So let's save this time. Let's check the plate thicknesses here. This is something I always recommend. You can see the lift points here, which kind of represent the clamps, okay, on both sides. These are modeled with axial member with a high stiffness, okay, and they are pinned at the top. And so 30 inches, you remember that number, this would represent the distance between this point here and the top of the flange. Let's look at the linear elastic solution. The displacements are small, but you can see the rotation here of the girder. This is something you can check using these charts here, the layovers. Okay, the layovers are the relative displacements between the top flange and the bottom flange. So if you divide these numbers by the web depth, you would get a rotation in degrees. And usually what is recommended is to have a rotation that's under 1.5 degree. You can also check the moment diagrams. Okay, you can check out your shear diagrams, torque diagrams. Okay, top flange lateral bending, bottom flange lateral bending. If you want to, there's some numerical discontinuities here due to the transitions. You can also, of course, check your stresses here. You can check sigma YY, but maybe why not check the torsion in the flanges or the torsion in the web. Okay, and let's now go to the buckling mode shape number 1. We've run an eigenvalue buckling analysis. You can see here that we've got an eigenvalue of above 19, so that's a pretty high, a pretty stable system, so no stability issues here. So again, we've got 3 limit states to check. Usually the end rotations, this is to avoid feed up problems, they should be less than 1.5 degree in general. That's the recommended value. We should also check eigenvalues. They should be above 1 to avoid stability issues, and 1 is not enough. Okay, so if it's 2 or 3 or 4 or 5, that's even better. 1 is too small, and 2 is probably also slightly close to 1. And the other thing would be to check stresses. The value of Fy over 2 is recommended. So you can find more information on this on the website. There's a dedicated presentation on lifting analysis. I hope this tutorial was useful to present you this new feature. Thank you.